The transistor is one of the fundamental building blocks of modern-day electronics, and its invention in the 20th century drastically revolutionized how electronics devices operate. The transistor is a small semiconductor device that is used to amplify or switch electronic signals and electrical power. Despite its minute size, its contribution to the world of technology has been monumental and transformative. Invented in December 1947 at Bell Telephone Laboratories by William Shockley, John Bardeen, and Walter Brattain, the transistor signaled a new chapter in the digital age, transforming and overtaking the existing vacuum tube technology. The first iteration of the transistor was the point contact transistor, which was then followed by the more popular bipolar junction transistor, BJT. In the decades that followed, more types of transistors were developed, including the metal oxide semiconductor field effect transistor, MOSFET, which is currently the most widely used transistor for amplifying and switching electronic signals. The significance of the transistor's invention cannot be overstated. Due to their design, transistors are able to regulate current or voltage flow and act as a switch or gate for electronic signals. This makes them a central component in nearly all electronic devices, from radios and calculators to computer systems and mobile phones. Moreover, they are notably more durable and long-lasting than their predecessor, the vacuum tube. Its small size and low energy consumption led to a drastic reduction in the size of electronic devices, while also improving their durability and efficiency. One of the most tangible demonstrations of the transistor's enormous impact is the development and broad proliferation of computers. Transistors function as fundamental components in the processor of a computer, allowing for billions of calculations per second. Without transistors, we wouldn't have the miniature supercomputers we carry in our pockets, known as smartphones. The transistor, the foundation of the integrated circuits, ICs, has also made it possible for us to create highly sophisticated technology, such as medical devices, communication equipment, and space technology. Despite the overwhelmingly positive influence the transistor has had on technological advancement, it is not without its negative consequences, particularly from an environmental perspective. The manufacture of semiconductor devices such as transistors requires a significant amount of energy and non-renewable resources. Moreover, it involves the use of toxic chemicals, which, if not properly managed, can lead to significant environmental pollution. Used electronic devices containing transistors add to the growing problem of electronic waste, e-waste, which, when improperly disposed of, further exacerbates environmental issues. In addition, the rapid pace of innovation driven by the transistor has led to an increasingly disposable culture in relation to electronic devices. As new devices enter the market, older ones are quickly discarded, adding to the current dilemma of waste. Furthermore, none of the negative impacts of transistors considers the potential consequences of the digital divide, the gap in access to technology between different demographics that could be exacerbated by rapid electronic evolution. In conclusion, the invention of the transistor marked a turning point in the development of electronics and digital technology. It amplified the speed and potential for technological advancement, allowing for the miniaturization of electronic devices and remarkable progress in fields such as telecommunications, computing, and many more. Nevertheless, the environmental challenges associated with the production, use, and disposal of electronic devices containing transistors underscore the need for sustainable and responsible practices in the electronics industry. With the ongoing digital evolution, understanding and addressing these challenges will only grow in importance.